Hello guys, now let us start question number 2 from Statistics 1 Pearson Edexcel A-Level exam. Exam was taken in January 2024. Paper reference code is WST01/01. The statement of the question is the average minimum monthly temperature X degrees Fahrenheit and the average maximum monthly temperature Y degrees Fahrenheit in Kolkata were recorded for 12 months. Some of summary statistics are given as below. Sum of x equals 862, sum of x square equals 62,802, and SYY equals 413.67, SXY equals 512.67, and N equals 12. Calculate the mean of 12 values of average minimum monthly temperature. If you want to find the minimum temperature, we know the formula for mean. First part is very easy. Formula of mean equals x bar equals sum of x divided by n. Okay, substitute the value. Sum of x is 862 divided by 12. We'll get the answer. To three significant figures will be 71.8 degrees Fahrenheit. So this will be the answer for first part. Now for second part, show the standard deviation of 12 values of average minimum monthly temperature is 8.57. We need to find that standard deviation of this data will be equals to 8.57. Two, three significant figures. Okay, here is a space. Let me write that. Question number 1, second part. First part is already done. Standard deviation formula is, you have to memorize this formula. Standard deviation is represented by sigma. We can write like this, and square root of sum of x square divided by n. This is the formula, you have to memorize it. Sum of x divided by n whole square. Now substitute the values for the given data. Sum of x square is given there. If you notice that it is equals to this one, 62,802. And sum of x equals 862. Just substitute these values in this formula, we'll get the answer. Sum of x square is 62,802 divided by 12 minus sum of x, that is 862 divided by 12, and take whole square. Just what I'm doing here, I'm substituting the value. Sum of x is 862 and n is 12. Same way, answer of this one is 62,802 and n is 12, so you can write like this. Use calculator to get the answer. Better you solve the values under the square root first of all, and you can do all. You can show this step as well. If you solve this by using calculator, you will get this answer under the square root, 36. And our answer to three significant figures will be 8.57 degrees Fahrenheit. Okay, to three significant figures. So this is the answer as required. Second part is done. We proved this one. Okay, now for B, calculate the product moment correlation coefficient between x and y. For that, product of moment correlation is represented by R. You should know the formula for R first of all. That is SXY divided by square root SXX multiply SYY. Got it? So this is the formula to find the product moment correlation coefficient. Okay, so let's see what values are given here. If you we see from here in the given data, SYY is given, this value is given there. Okay, and SXX is not given, SXY is given. So you need to find this value first of all. Got it? Let me write this stuff over here in the given space. For second part, we know the formula for R, that is equals to SXY divided by square root SXX multiply SYY. So you need to find this value first of all, and you know that this SXX denotes the sum of deviation from the mean, square of the deviation from mean. So there are two formulas for SXX. that is equals to sum of square of deviation from mean. X minus x bar is called deviation from mean. This is called deviation from mean. If you take square of this, you read as square of deviation from mean if this symbol is there. So overall you can read the definition like that: sum of square of deviation from mean. Okay, one formula for sxx is this one. Same way you can make the formula for syy, and you could make the formula for sxy. Okay, but here we need to find only this thing. Or you can use there is another formula for this, that is equals to sum of x square minus sum of x whole square divided by n. So this is the formula. Plug in the values of sum of x square and sum of x over here. You will get the value for sxx. Okay, let me write the values for sxy from the given data that is given in the question. That is equals to sxy is 512.67, 512.67, and value of syy is equals to 413.67. That's it. Now substitute the values for sum of x square from the given data that is given in the question, that is equals to 62,802, minus sum of x is 862. Because it is square, you will take square of this and divide by 12. Solving it, we get the answer as 881.67. Now we have all the values given of formula for moment correlation coefficient that is given above. Substitute all these values, these three values in this formula, we will get the answer. That's it. So R will be equals to 512.67 divided by square root of 413.67 multiply, you can use this symbol, 881.67. Write your answer to three significant figures. Our answer will be 0.849 to three significant figures. So this is the answer for second part. Let's move back to the for the next part. Next part starts from here. For comparative purposes with the UK city, it was necessary to convert the temperature from degrees Fahrenheit to degrees Celsius. The formula used for C equals 5/9 into F minus 32, where F is the temperature in degrees Fahrenheit and C is the temperature in degrees Celsius. Use the formula and the values from part A to calculate in degrees Celsius. The mean and standard deviation. Mean we already got it, that is 71.8. This is given in Fahrenheit. Okay, mean in Fahrenheit. And standard deviation, this is also given in Fahrenheit. Okay, first of all, let me write the formula for C. That is equals to 5/9 into F minus 32. Okay, from here you could find the mean. So you can make the formula for mean. So this mean will be in degrees Celsius, 5/9. Here you can replace this one by x bar that is given in Fahrenheit minus 32. So here you will use the mean for Fahrenheit. That's it. And use that mean over here, you could get the answer in degrees Celsius. 5/9 into, so mean was 71.8 minus 32. Okay, and you get the answer in degrees Celsius. Solve it by using calculator. Your calculator gives you the answer 22.1. So this answer will be in degrees Celsius. So this is the first answer for this part. This is the mean in degrees Celsius. Actually, this is the coding formula given because something is multiplying over here, something is subtracting. So mean is affected by all these factors, by addition, by subtraction, by multiplying. Okay, mean is affected by all this stuff if you are using the coding. Actually, this formula is given in coding, like you are subtracting something from Fahrenheit and then you are multiplying. So this type of conversion is called coding. But in coding, standard deviation is not affected by addition or subtraction. Like we can say that in coding, standard deviation is not affected by addition or subtraction. Therefore, we can make formula here. We can ignore this minus in this case. This is subtraction. Okay, something you are subtracting from F. So in case of you are finding standard deviation, you will ignore this. Okay, so if you want to find the standard deviation in degrees Celsius, therefore we can make formula like this: 5/9 multiply by standard deviation in Fahrenheit. That's it. Hopefully you understand this stuff. Okay, we will ignore this minus 30 in case of finding standard deviation. So standard deviation we already found in previous part, that is equals to 8.57. Substitute that value over here, we get the answer 5/9 multiply 8.57. So the answer for standard deviation in Celsius will be 4.76 degrees Celsius. So this is the answer for the other part of this C. Okay, so this is done. Part C is done. For the next part, given that U is the equivalent temperature in degrees Celsius of X, V is the equivalent temperature in degrees Celsius of Y. State giving a reason the product moment correlation coefficient between U and V. Okay, now the temperatures are U is the equivalent temperature in degrees Celsius of X and V is the equivalent temperature in degrees Celsius of Y. Now you need to find the product moment correlation coefficient between U and V. Here we already found the moment correlation coefficient between X and Y, so it will be the same actually. Okay, here you could give the reason. We already found R, it will be 0.849. We can say that for the last part, R will be equals to 0.849. This will be between U and V. Now you could give the reason. R will be same as it is not affected by linear coding. You could give this reason, to justify your answer. This is all about question number 2. If you have any doubt, any question, please write in the comment box. Thank you.